In this video, I'm going to talk about regression, specifically quadratic regression. But first, let's review what you already learned in Algebra 1. Linear, quadratic, and exponential functions were taught to you, and each one had the process of regression, which means finding a line of best fit that goes through the data to predict, to find future values. And each one gave you different numbers. The linear gave you the m and the v. These variables represented slope and y-intercept, which created your equation. In quadratics, we had the a, b, and c variables, and these gave you values that created this standard form equation of quadratics. And the exponential gave you an a and b value, which created the exponential function for that line of best fit. So we're only going to focus in quadratic regression in this worksheet. A, b, and c will be the values that will be given to you, and they're going to be given to you in decimals if they're not a perfect alignment between the data, if there is no perfect alignment. So if they do give you decimals, it's recommended for you to find, just round it to the 2 decimal spaces after the decimal, which is the hundredths, just to get an approximation of a closest number possible. Don't just stick with the whole numbers, because that will not be the closest possible. Okay, so first we're going to kind of analyze what the situation is talking about so we can have an idea of what we are predicting. Here they're talking about a pumpkin tossing contest, and it's using catapults to send pumpkins the farthest possible. Here in this data, we're talking about the catapult being placed at different angles, and then according to the data, this is the distances that the pumpkin lands according to the angle that is placed. So we're going to use this data collected and create a quadratic standard form. So in our calculator, we're going to go to Home, which is this main section right here, and then New. We are going to put No if there's any documents opened already. Add List and Spreadsheet, and what this does, it creates a mini spreadsheet, kind of like Excel or Google Sheets, where you input data in here. This program is for you to tell the calculator that you have information in a table that you want the calculator to process into creating an equation to. So our A will represent the X values of our table, and the B will represent the Y values. You have to assign these values first before you input the data, so the calculator knows what to do with those values. So on the left side, we have all the X values, so we're going to type them: 20, 30, 40, 50, 60, and 70. On the Y values, we're going to type 372, 462, 509, 501, 437, and 323. At any time, if you feel this video is going too fast, you may pause it or rewind it as necessary to learn the process. So next, we're going to go to Menu, and we're going to go to Statistics, Stat Calculations, and Quadratic Regression. This will take you to now identifying what you want the calculator to use as the X list, which is your X values, and then the Y list will be your Y values. You press OK, and here are your A, B, and C values. Once again, they are decimals because it is an approximation. So we're going to round this to 2 decimal places, and we are going to write our equation as y equals negative 0.26 x squared plus 22.59 x plus 23.03. So let me just go ahead and show you what that looks like. So this is our standard form equation of the line of best fit. Now some of you are visual, so you may want to go the different route of creating a visual representation of what we just discovered. So you will do Control Doc and then Data and Statistics. And this creates a visual of what the data looks like. So you need to rearrange it correctly. Click down here and select X for the X axis, and click here, select Y for the Y-axis. So it creates that visual of what the parabola looks like. You can also then go to Menu, Analyze, Regression, and Quadratic, and it'll create that parabola that goes through the data, giving you as well the same equation we just found. And if you have any questions, like I said, pause or rewind to rewatch the process to calculate this. So now that we have our quadratic regression equation, we are going to now predict. So it says, using the line of best fit, estimate the distance the pumpkin travels at 55. So if you look at the table, 55 is not here, but if it was, it would be right here. So we are going to find what value we can imagine will go in there. But if you notice that values are not changing at a constant predictable way, so it's gonna vary. That's why we use the quadratic regression to predict that. So this pretty much means that if your angle is the x, we're finding what y value do we have when x is 55. So there are two ways you can find the answer for this. You can do it mathematically, which is just going to your calculator and typing in here the equation that you had. So you're gonna have a negative 0.26, and instead of x, you're gonna type the 55. So pretty much substituting the 55 inside your equation for the x. Plus 22.59, and insert the 55 again, plus 23.03. So by pressing enter, I'm able to calculate an approximation of what the distance will be if my angle is 55. Okay, so now this is the mathematical way. The graphical way would be actually going to the graph and calculating what the 55 will be, what the y value will be when x is 55. So let's go ahead and type our equation in here. Okay, plus 23.03. Alright, so then now here is a piece of our parabola. If you want to just jump straight into the predicting, we can go to trace and graph trace. And again, this flashing dot, you can move it left to right and it moves along the parabola. But you can also just type the x value that you're looking for, which we're looking for 55. So then we press enter, and there is the prediction right there at 479. So that is pretty close to what we calculated mathematically. So we can just say that the prediction here is that when x is 55 degrees, we have a 479 foot distance of the pumpkin landing from wherever it starts. So that is the process of predicting. Now the last part is finding the reasonable domain and range for this function. So we're going to kind of sketch what's going on here. We know that it's a catapult launching 25 feet above the ground. That means that it starts up here at 25 and it's gonna go up and then come down. So the ground is the 0. Okay, so when we have the ground here at 0, we know that when it lands on the floor, that could be considered your x-intercept or your 0, however you want to remember this being represented as. And then your highest value, the y value that's over here, that will be your maximum. So when we find our domain and range, we're looking at the left to right. What is the minimum? What is the smallest x value we're looking at? And then what is our maximum? What is the highest x value? For range, we're looking at it up and down. What is the lowest y value? And then what is the highest y value? So we need to go back to our calculator and calculate the max and the 0 to find where that is. So we will go to the graphing part and go menu, analyze, maximum. And because we don't have the parabola in the screen, we're gonna have to go back and zoom out. So menu, window zoom, and zoom out. So zoom out until you see, there you go, a maximum. So now we do menu, analyze, maximum, click on the left, click on the right, and there is your maximum. X, comma, y. This y value, that is your highest distance that it was created in the prediction. So 514 will be considered your maximum. And now we're going to write what the 0 is. So we trace down here. We can go one more zoom out just to kind of see where it intersects on the X. Actually, 3 more. Nope, 4. There you go. Now we can see it. So we're going to do menu, analyze 0, and we're trying to find this 0. So we're going to click on the left side, right side, and then there you go, 87.9. So in our paper, in my sketch, I'm going to write that the 0 is 87.9 and that the maximum was 514. So we write our domain and range. Left and right, we're looking at 0 being our minimum and our maximum being 87.9. For range, our 0 is our minimum and our maximum was 514. So this is pretty much our minimums and maximums, and we kind of just analyze whether we put equal to or not. We do know that it's reaching 514, so we put as an equal to. We also know that it is touching the ground, so we do have our minimum value of 0. As far as the domain, we do know that it lands on the floor 87.9 at the end, and then the 0 is where it starts. Okay, so that is how you will complete one whole problem in the quadratic regression. You would use the table to create an equation and then predict the value. And then also don't forget to have that analysis of reasonable domain range. I hope this video helps you, and I will make part 2 and part 3 and part 4 for the next 4 problems. Let me know if this helped. Thank you.